Hello everyone. Thank you for joining to this stream. Hopefully that's going to be interesting for you. Please comment and say hi so I know that you're there and I'm not speaking to myself here. And let's wait a minute for others to join and we'll start shortly. During this meeting, I will share a bit of my personal story regarding how the Internet of Things journey started for me, how it proceeded and how it ended. Hello? Hello? Okay, so it looks like we've got at least Sami with me. So, hello. In that case, let's start once again. Uh, Welcome. And yeah, let's start this meeting regarding the journey of IoT, how to enter that, and how to proceed. My name is Łukasz Majlowski. I'm the Internet of Things advisor and trainer. Over 15 years of experience in IT, over 7 years focusing on the Internet of Things domain. So it looks like quite a long time and well-structured path. But to be honest, it is not that great. Right? I could have organized my journey way better, and that's what I want to share with you. Because there is one thing that you won't find in those numbers, one thing that you won't find on my LinkedIn page, and this is this little star, right? It basically means that I played with the Internet of Things concepts for over 20 years. Of course, it was not called the Internet of Things back then, right? But this is the area that I really entered a long time ago. But because of some random path that I took, I did not fully benefit from learning and from all of that experience that I could have gathered. And this is what I want to share with you, how you can avoid my mistakes, hopefully learn from them, and how I can assist you in that journey. So what has happened? My approach started as solving random puzzles. So basically, I was figuring out some crazy random puzzles to solve. Sometimes it was simply installing a Linux operating system on some device that was not designed to be running Linux at all. And obviously, I failed most of the time. But sometimes I succeeded. And when I succeeded, I marked that puzzle as solved and moved forward. And that was the huge mistake, right? Because what I did is I created interesting capability. Like I extended some awkward device with Linux operating system and could benefit from that, could create better end user experience, could done some interesting concepts in terms of providing business value, right? But unfortunately, I did not think in those terms back then, and I just moved forward, which is a shame, right? But this is what it was. Nowadays, I look totally different on the way how to gain knowledge and how to experiment in the Internet of Things area. So at some point on my journey, I decided that I'm doing something wrong and I need to get a bit more organized. And I found two main obstacles in the way that I behave that prevented me to move forward in an efficient way. And those obstacles were friction and distractions. So, what do I mean by that? By friction, I mean anything that is not purely related to the task that you want to achieve. For instance, if I buy a new shiny piece of hardware because I want to create some proof of concept experiment, there's a friction because you need to set up this hardware, right? In the initial setup takes time. You need to understand how it works, and sometimes you need to learn a new language to develop the firmware or software running on that specific hardware. And with new language comes a distraction, because for me, like using new tools like new programming editors, new stack. That was like new toys. So I focused on basically my new shiny code editor, some kinds of plugins, all of that stuff, and totally forgot about why I even bought that shiny device in the first place, right? And that created this cycle that was really hard to break until a few years back when I really sit down and be honest with myself how I proceed. And I found a way how I can actually be very specific in my research and be very effective in doing so. And this is the path that I found. And if you do not agree with this approach, please comment, because I'm really open to feedback. If you agree with this approach, please comment as well if you got any questions. Because this is not the path that I took myself, unfortunately, right? This is just a thought experiment based on tons of my own mistakes. And this is the message to younger me, that if you're just starting the Internet of Things journey, please consider taking that approach, because it hopefully will be way more effective than doing some random research that I used to do like many years. So the very top of this path, we've got the theory. So you need to understand the IoT value proposition itself. So why you even bother learning about Internet of Things in the first place, right? Maybe this is something that does not really provide any decent value to you. Maybe there are better ways to achieve what you are aiming for. So this is the first and the very important topic, because at the end of the day, the IoT, the Internet of Things, is just a capability of sending data from devices to some kind of backend and sending commands from the backend to those devices. And of course, you can implement and deploy some logic onto those devices as well. But at the end of the day, the IoT is just a capability. It is not the end goal by itself. So please be aware of that, and do not focus on those shiny toys as I did for many years. Focus on what you are trying to achieve, like the business vision, or maybe some goal that you want to achieve. And once you do that initial research and decide that the Internet of Things is the way to go, I strongly recommend that you start with the simulated environment instead of buying some shiny education dev kit hardware, right? Which like you might don't agree with that, and I know that there are tons of interesting hardware right now that we can choose from. But let me give you my reasoning why I really strongly suggest starting with simulated environments and then proceeding to the hardware once you got some kind of hands-on experience and understand what you're doing. So when you've got a simulated environment, you've got full control. So first of all, regarding the communication between devices and backend, or between devices and devices, that should work. Like there should be any random glitch as you've got in real life connectivity. You should not run out of bandwidth, network coverage, all of those real life issues hopefully are eliminated in simulated environment. And if your device cannot reach the backend, that's probably because you messed up the configuration. Maybe you messed up the logic on the device. Some privileges are not set as they're supposed to be, right? But this is not the issue outside of your control. This is basically your mistake, and that's totally fine because you're learning, and this is the way it should be, right? I learn the most when I do some debug of issues that I created myself, to be honest. Right? So once you're comfortable with the communication, so you know how to make your simulated device talk to your backend and how to make your simulated devices speak to each other, then you can take one step further to the device management, right? Because device management depends on the connectivity and the communication between devices and the backend, plus adds a bunch of use cases on top of that, right? So at this stage, you've got communication figured out. You can focus on those device management use cases. And still, using simulated environment is totally fine. You can manage simulated devices the same way as you will manage hardware devices later on. And once you've got device management figured out, you can move to the fleet management, right? So you add a bunch of simulated devices, which actually eliminates lots of friction for you if you use simulated devices, right? Because you can spawn as many as you wish instead of trying to buy additional hardware and build some kind of fleet yourself. And when you work with fleet of devices, then you need to automate lots of steps that you previously done by yourself. And that's great because this is the way that I think is best to learn. Then first you do every single step manually, then you add some kind of automation, maybe leverage some AWS services to do part of that automation for you, right? And once you're comfortable with fleet management, with initial device onboarding, with credentials management, all of that stuff that comes under this umbrella, only then I would suggest you start with the actual hardware deployment. Because hardware brings tons of friction by itself, right? And at least on this stage, you know your backend good enough, you know the communication, you know how the edge device should behave, that you can distinguish between the issues caused by the hardware itself and some other random bugs that you've got in your code, right? And your backend is also prepared in a way that you can debug issues with your communication using the hardware, the backend setup. And the same goes with the connectivity, right? You've got connectivity figured out using the simulated environment, and now you can debug any random issues with the real hardware connectivity to the cloud backend because you know how it should behave and you know what to expect, right? So that's the overall idea of the path that I suggest. And yeah, well, hopefully it makes sense for you. If not, please comment. Let me bring up one comment. Okay, well, I think what you proposed is, let's say, longer time span that what I'm talking about, right? Because implementing the IoT frameworks for data acquisition and then machine learning models on top of that, this is basically next step in the journey, right? And what I focus on is the foundation IoT knowledge and skills, basically, right? So you need to go through the path that I proposed in order to even start thinking about building a framework. Because if you want to implement a framework, like your own framework, then you should have pretty good skills in managing in field management, basically, right? So yeah, I agree with you that this is an interesting extension, though I would still recommend starting from the basics because the basics are difficult enough in the IoT space. And there is one additional category that I missed out, which is the security, because this is tricky part in my opinion, because you should be security aware to start the whole journey, right? But being security expert is not mandatory at all. And what I recommend is that let's try to always think about what can go wrong. Like, so if you connect your device to the backend, right? Is there a way that someone could pretend that that person owns your device, and this way would try to hack your backend to get access to data that person should not be able to access. And security is something that basically spans from the theory through the simulated environment, ending at the hardware deployment itself. And once again, hardware adds additional security challenges, additional security friction to the whole topic. But this is something that once you understand better and better how the whole IoT space works, then you will be able to see the security challenges and address them along the way. This is how I would suggest. That's why I put the security across the whole stack. Okay, so that was the overall path that I suggest, and I was speaking a lot about simulated environments, about working with simulated devices. Right. Thank you very much for that comment. Yeah, I'm doing my best to share my own experience and my own mistakes with the community, just to make everyone yeah, achieve their goal faster. So that's what I'm trying to do. And that's why I created this IoT Lab. And this IoT Lab is aimed to limit the friction and distractions for you. So the issues that caused me most trouble, because this is the preconfigured lab environment. So that means that I personally took all of those moving pieces, made all of those decisions for you, and creating a bundle called that IoT Lab. So everything works out of the box. You don't have to configure anything. You don't have to take any decisions. Of course, if you do not like how it works, this lab is free and open. You can modify it to meet your needs. So that's totally available. I would just strongly recommend that you play with it for some time just to understand all of those moving parts, and then you're totally free to change those relations to use some different tools. And this IoT Lab is production ready. And what do I mean by production ready? I mean that it is not some kind of sandbox environment. The tools and the solutions I propose within this IoT Lab, they can be applied to the production. And I applied them to many production deployments that I've done in my career, right? So I'm not saying that the IoT Lab is the best tool to develop the custom automation, for instance, right? But once you develop custom automation using your IDE, you can test that automation using simulated devices within this IoT Lab. So that's basically the whole idea. And let me show how you can use it. If you are interested, you can check it on the fingrex.com/lab. And that will bring you to this page where you can find a bit more details about this lab, how to deploy it. I even created a short video following you through the whole step. I said that the lab is free, and that's totally true. But you need to be aware that by default, this IoT Lab runs on the AWS EC2 instance, and you will pay for the underlying instance, right? So that's the cost that you need to be aware. It's not the cost that I charge for this lab, because I do not have any income if you're using this lab, but you need to be aware that you will pay for that instance. And you might ask, okay, in that case, I don't want to pay for that instance. I just want to create the whole thing myself. And that's totally fine. Yeah, you can do that. But that would introduce the friction and distraction that, at least for me, it totally destroyed my focus on what I was trying to achieve. That's why, even though it will cost you like not that much, but it still, right? I do believe that starting with this IoT lab on AWS is a good idea because it will work out of the box for you. You can understand all of those concepts, and once you are comfortable, then you can deploy all of that on your laptop because there is no magic at the end of the day, right? It's just set of tools that are pre-configured to work to each other. Okay, let's move forward. Let's go to my AWS console and let's find CloudFormation service so we can actually deploy this lab. Okay, once again, CloudFormation. And let's create a new stack with new resources. A bit bigger. Leave the template is ready and use Amazon S3 URL. And for that URL, you need to use this link, which is available on my page as well. Let me just scroll on to grab it. And this is simply a CloudFormation template that creates the whole environment for you. Go next. You can call it whatever you want. I will call it my demo for now. Next. And leave default configuration. Once again, we try to limit the friction and distraction, so don't bother. And in review, you need to acknowledge that this stack will manage your IAM resources. And that's very important because we are working in this case with AWS Cloud. In order to create resources, to manage cloud resources, we need to have the IAM permissions. And we need to have those permissions also to make AWS services to talk to each other. So that's why we need to acknowledge that and hit submit. I will not submit because I already created this stack for us, so we don't have to wait. But this is basically the final step. And once your stack is ready, you can go to it and go to the outputs. And here you will find a link to your notebook, which is used to host the IoT Lab itself. And this is the instance that I was talking about, right? This is the EC2 instance that is used to host this lab, and this is what we are paying for. Just a sec, let me catch up on comments, and we will proceed with this IoT Lab review. Yeah, so thanks for that comment. To be very honest, I do not work at AWS anymore. Like I used to work at AWS as an IoT consultant for years. I'm not working there, so my honest and private opinion is that it is totally correct that there is a lack of IoT materials and real IoT training. Like not something that is focused on the sandbox, but shows you how to manage your production deployment, right? Even the official database documentation is not always showing you the most secure and efficient way because it is sometimes a bit tricky to achieve that state. It is showing you the easiest way that is kind of secure and efficient, but you can do better than that. And this is what I'm trying to share both in this training and in my content. So I totally agree with you. You're welcome. I hope that is relevant. Okay, let's move forward. Let's open the IoT Lab. I'm using the Jupyter notebook as, let's say, the main tool to organize all of those moving pieces. And I'm aware that Jupyter Notebook by itself kind of brings some friction and might be a tool that you're not familiar with, right? Because this is tool that is commonly used in the data science environment, but it is not necessarily that well known in the IoT space. But still, I do believe it is worth trying out. Let me refresh the page because it looks like something is off. Yeah, there we go. Okay, and this is how it looks in a second. So, in order to work with this lab, you need to use some training materials. I prepared a demo session materials. Let me upload it. I'll just drag and drop a zip file. And in order to make that convenient for everyone, I created this little install notebook so we can just unpack that zip file. If you never used Jupyter, just click on that play button and it executed also. And this is the demo session that we actually want to use. And this is very, very important, right? Because this might be a bit awkward if you never used the Jupyter notebook. You need to select the kernel, and the kernel that we are looking for, at least for these materials and any training I prepare in the future. This is the Conda Python free kernel, right? So this is basically the basic Python free runtime, and that's all what we need. And this is how the lab looks inside. Just a bit bigger. If you never used Jupyter Notebook, I even created a short introduction. Once again, we need to check the kernel, and this is very, very brief intro of how to execute cells, what kind of cells you've got in the Jupyter Lab notebook. Hopefully that will be enough to get you started. And training materials are available on this URL. You can find it on the page. So if you want to follow along, just use this URL to deploy your stack. And if you scroll down, you will be able to find training materials and the demo session. This is exactly the link that I'm showing right now. So feel free to grab it. Feel free to play with it. So let's get started and see how you can actually leverage the hello Anya how you can actually leverage the lab itself. Let's make a bit. First of all, we need to install some tools. I told you that those tools are pre-installed for you. We are using the AWS managed instance as a base, and as you can see in this case, it got a bit outdated packages. So this is just a good practice that you upgrade those packages. All of those commands are embedded into the training notebooks itself, so you don't have to worry about it. You just need to execute them every time you start the environment, and it will upgrade you to the latest versions. And we're done. So now we are ready to open the configuration file and see what is inside. We can use this link, and as you can see, not that much, but still, as a good design practice, I strongly recommend that you use the config files to manage consistent namespace, for instance, to manage your infrastructure in a way that is consistent using multiple different scripts. So that's why I use it even in that trivial example to kind of create that behavior that you should use this kind of configuration files. Let's read data from this file to our variables. And to manage AWS infrastructure, I strongly recommend that you start with AWS SDK for Python, the Boto free. You can find a link to the official documentation here. And why I advise doing so? Because it allows you to execute every single AWS API and to check the output. So you know what's going on under the hood. There's no magic that happens. You are responsible to manage every single resource, and you are responsible to create relations between those resources. So this way you can learn and really understand how the whole infrastructure and how AWS services are organized. And there is additional side benefit. So CloudFormation does not support all of AWS IoT capabilities. And that's a huge pain. It always be like that, and probably will stay in the future. So even if you use CloudFormation or other tools to manage your infrastructure, you will have to do some SDK level changes to make the whole thing work for your IoT environment. That's why knowing SDK is just a good starting point, and then once you understand how it works, it's easier to use some higher level tools like CloudFormation, for instance. Let's create the bot-free session. From that session, we are creating a client, the IoT client. So using this client, we can interact with IoT services of AWS. And the main entity in AWS IoT is the IoT thing. So the IoT thing is a virtual representation of a physical device or a logical entity, like an application. So in this example, we've got our temperature sensor that is represented as an IoT thing in our AWS IoT registry. And those are the properties of a thing. So we've got thing name, thing type, attributes, groups, and shadows. I will not go into details during this demo session because it would take way too more time than we've got. I just want to show you how it looks. And I always advise to manage your infrastructure from the code, so using SDK or other tools, and check the outputs using the console, because this way you will have really good understanding of how the whole system behaves. And as you can see, I do not have anything registered in my AWS account. So let's create our first IoT thing. And this is a sample execution of the create thing method. As you can see, it maps pretty closely to the properties of the IoT thing. So once you understand some concepts and how all of those entities are organized, it is pretty easy to find your way around and manage your infrastructure this way. So let's list all of the things. As you can see, we've got 200 output code, which is usually a good sign, and we've got empty list of things. That basically means that there is no IoT thing registered in our IoT core. We already verified that from the console, so this is expected. And now we can create our first IoT thing, and it looks like this. We've got the demo thing, and we've got 3 attributes. And those attributes are not some random attributes that I put here. This is something I strongly recommend you add to describe your things. So first we've got the firmware version, then we've got hardware version and vendor, which is kind of optional sometimes, but it's still good to have as the attribute of your IoT thing. And why do I say that those attributes are kind of mandatory? Well, they are not mandatory. You could put whatever you want. But once again, we are looking at this whole concept from the production ready perspective to get best design principles and practice to create production setup. So when you got an IoT environment, you probably will have tons of your devices, and after a few months or few years of operations, you will have devices running different firmware versions and even different hardware versions. And firmware and hardware that specifies what type of actions you can execute on that specific device. So you really want to be able to get all devices of specific firmware or hardware and execute some action on them, and not execute that action on devices that are not capable of doing so. And regarding firmware version, in the IoT space, there is a way to upgrade firmware remotely. It is called the OTA, the over-the-air firmware upgrade. And for hardware, well, unfortunately, there is not an easy way to upgrade hardware remotely. So it is what it is. Anyways, let's create our first IoT thing. Once again, it looks like we succeeded. We've got the output with the thing name, thing ID. So let's list our things. As you can see here, we can find our things. And because we are managing this infrastructure from code, in this case from Python, we can leverage Python to work with this data, basically, right? Because the IoT infrastructure or AWS infrastructure in general, when you work from the SDK perspective, those are just some abstracts. This is just the data. So we can invoke the same SDK once again, but limit the output only to the things. So then we can iterate, for instance, on this list and invoke whatever function we need to invoke on this specific list. We can then get some additional metadata about this specific thing. And here I would like to highlight this piece of code. I know that we are getting a bit deep in terms of programming stuff, but if you're starting, right, I want to help you start in a proper way. And one of the things regarding the proper start and is not to hard code names of your things. So you can then manage the whole fleet in very dynamic way. You can change the names whenever you need and just run your your scripts. So here what we are doing is we are getting the thing name from the attribute of the demo thing, which is the output of this call that created this specific thing, right? So this is the way that we can dynamically get this data. And once we execute it, you can see that we've got some additional details about this thing. We got its name, ID, and whatnot. If we go back to our AWS console and refresh this page, you can find this demo thing here. So that's very brief introduction about managing devices. Let's clean up and remove this IoT thing because we do not need it anymore. And I would like to admit to something. Like I said at the very beginning, and this is something that I say often, which is not totally true, that IoT thing is a representation of a device in the AWS device registry. In reality, to fully represent a device in AWS, we need to have its proof of identity, which is the X509 certificate. We need to have its metadata, which is the IoT thing, and we need to have its permissions, because you don't want your smart washing machine to open your smart door lock and let everyone in. Like you need to narrow down what those devices are allowed to do, what types of messages they are allowed to send. Speaking about messages, using this IoT Lab, you can learn the MQTT protocol. And the MQTT protocol is one of the most popular protocols used in the Internet of Things domain. So, like very, very high level introduction, because we are kind of running out of time and I want to cover one additional topic, is that you've got three actors in the MQTT session. You've got the publisher that publishes the MQTT message. We've got the subscriber that subscribes to MQTT topic to get messages from the topic. And we've got the broker in between that facilitates the whole communication. So if you look at those arrows show how the actual session is established. So the publisher connects to MQTT broker and establishes the session to send MQTT message to a specific topic. The subscriber connects to the broker and subscribes to top MQTT topics to receive the message. And the logical flow is that the publisher publishes the MQTT message and it goes to the subscriber, right? But you need to be aware that it is not strictly like that. It is you need to establish those two sessions between that message can be delivered. So this is extremely high level introduction to the MQTT. And if you go further to this demo session, you will find how you can start a terminal, how you can execute the commands to create the MQTT broker. So Mosquito is the open source MQTT implementation both for the broker and for the clients. I really uh, like using this tool because it allows you to play with MQTT, with like go really deep in terms of which capabilities of that protocol you want to learn, and it's just a good tool to know both for the experimentation, for learning purposes, and for the design purposes as well. So this is how it looks. If you're interested in this topic, feel free to grab this demo session materials, set up your own AWS IoT Lab, and invoke those commands to see how things works. Now let's go back to my presentation because there is one final thing that I would like to share, and this is the introduction to IoT at AWS training. So if you decide that what I'm talking about makes sense and you're willing to spend some money to help me guide you in your IoT journey, then there is a training that I offer, and you can find it on my page, the fingerx.com/training. And that training covers the best practices in learning about IoT at AWS that I came up with. And this is with the reasoning I describe throughout this session. In this training, I cover the principles of the Internet of Things itself. So you know what type of capabilities you're creating, and you need to figure out how to use it to provide a business value. I will, of course, show you some sample use cases, but you need to be aware that IoT is just about capability. We will go deep into the AWS IoT core device registry. So the way to keep information about your devices in AWS, both about the identity, metadata, permissions, and whatnot, how to establish trust in distributed IoT environment, because IoT environments tend to be very distributed, and creating trust in this type of environment is not an easy topic. Then I will cover the X509 certificates as a proof of identity of your devices. So your backend can verify the identity of devices, and devices can verify identity of the backend and themselves. Then we will go really deep into the MQTT protocol and best practices regarding design the MQTT topic structure. Because at the first glance, the designing MQTT topics seems to be extremely easy, but it is extremely difficult, to be honest. And yeah, so you need to really think how you want to organize your system, how you want to manage it in the future, and work backwards from that, and design a topic structure based on that. Then we will go to the end-to-end message delivery in distributed IoT environment. And finally, during this training, I highlight important limits of AWS IoT Core Service. If you work with AWS or any other cloud backend, you really need to be aware of the limits of services that you're using, because otherwise you will have some nasty surprises. So that's why I include this topic also to the training. Even though it is kind of introduction, you should be really aware of the challenges in front of you. So that is it. Thank you very much for your attention. And we've got 15 minutes left. So if you've got any questions, comments, I'm here for you. Well, yeah, that's true. Like the uh, cloud is just one piece of the puzzle, right? So and this is actually what I really, really love about the whole IoT thing. So it is not only the cloud or any other backend with some kind of application, right? It is also about the hardware, the firmware, and what I really like to say is that, in my opinion, the Internet of Things is the physical manifestation of the software components, right? So basically, when you see a device that behaves somehow and use actuators to impact its environment, then basically what you're seeing is the piece of software impacting your reality, which is like extremely interesting for me. Is there- Mhm. So that's a great question regarding the state management. Um, there are a few ways to handle it. Typically, if you want to track a state of a device, you use the uh, capability called the device shadow that records the last known state of that device. So if you want to, let me just go quickly to my console. I got to look it out. Okay. Anyways, so if you search for the device shadow, this is basically what you want to use because device shadow is a JSON document that is stored in the IoT core on the AWS side, and it keeps track of two states of a single device. The desired state, so the state you or the backend wants that device to have, and the reported state. So the last known state reported by that specific device up to the cloud, right? And this way you don't have to query your device constantly if it is alive or not. You can use device shadow to determine that. Mm, yeah, well, if you want to, you can also implement some kind of mechanism like the health check, but typically it's not. Yeah, typically you handle that differently. Like if device is streaming, for instance, if device is streaming telemetry data, then basically you expect that data to arrive, let's say, every 5 seconds. And you can create an alert that if data for that specific device will not arrive within, let's say, 15 seconds time window, you want to take some actions. So this is how you handle that. Okay, everyone. Last chance for last questions. All right. So hopefully, what I shared with you was interesting. Please consider using that approach to your own IoT journey. I'm not saying that you need to like go straight and buy this training. Um, just plan what you're learning and why you want to get that knowledge, right? Because this is the huge mistake that I did. Let's say that I learned a lot of random things without really thinking how I will apply them in the future. And yeah, so at the end of the day, it worked out pretty well for me because all of those random pieces of knowledge provide some kind of value if you work with really edge case scenarios. But I would say that this is for sure not the best way to learn about this area. So once again, thank you very much. If you've got any questions, reach out to me. I will do my best to help you in your IoT journey whenever you are starting, you're in the middle, or if you're an expert in this field, or you've got some idea about the business service or product, reach out. Hopefully, I will be able to help you. So, with that said, thank you very much. I'm Łukasz Malinowski, the Internet of Things advisor trainer. All the best.